Alright, our last chapter dealt with circles and their properties. Okay, there's a few equations, a few different formulas we had. We'll kind of go through those as we go through this section. So let's get going with that here. Okay, problem 1 says lines that appear to be tangent are tangent. What's the value of x? Okay, here the big thing we're dealing with is a tangent line to a circle. That's going to be a line that intersects a circle at a single point. And the big theorem we had dealing with tangent lines is that the tangent line and the radius of the circle are going to come together. They're going to intersect at a right angle. Okay, so anytime you see tangent lines to a circle, you should be thinking right triangles, and then we can use all our different properties of right triangles, okay, to solve for some different parts. Okay, we want to figure out x, and to do that, we're going to deal with this bigger triangle here, this right triangle. But notice I actually don't know any angles in that besides the right angle. So to start off with, what I need to do is break things down into the smaller triangle. Okay, so now since both these segments coming out of the center of the circle are radiuses, or radii we'd say, I know that these two angles will be congruent to each other. This will be 56 degrees. Okay, meaning we can find this central angle right off the bat. If I go 180 minus 56, that's going to give me 68 degrees. Okay, then once I have that 68, I have my 68, the right angle here again, and we're looking for the third angle of a bigger triangle. So if I just take 180 minus 68 minus 90, that'll give me that x equals 22 degrees. Okay, so it looks like option 8 here, 22. Again, big thing from this problem is that when we have tangent lines, we know we have that right angle with the circle. Alright, next one, story problem. Let's read through this and kind of talk about what's going on. It says Jeremy is the set designer for the school play. The center of the circular stage he's designing is at point P. Okay, walls of the stage are represented by SP, PT, RS, and RT. Using the angle and arc measure in the diagram, what's the measure in degrees of angle RTP? Okay, so we want to figure out this angle RTP here. Okay, I'm going to label that right off the bat, R to T to P. It's going to be this angle by T on the side of the circle. Okay, it looks like what we're dealing with here are inscribed angles and intercepted arcs. Okay, inscribed angles and intercepted arcs. When we said an inscribed angle, we just meant an angle that fit perfectly on the circle. Okay, its vertex is on the side of the circle. And then the intercepted arc would be an arc made up by the inscribed angle. Okay, formula we had for those is we said that angle is equal to 1/2 times the arc. Okay, so if I know the angle, we can figure out the arc, or if I know the arc, we can also work backwards, figure out the angle. Okay, so let's get going with this here. Now, the arc I'm given, RS of 76 degrees, that's actually going to correspond with this larger angle. Okay, STR we could say. So that's not actually what I'm looking here, but it's going to give me a start. I know that that angle is going to be equal to 1/2, okay, times the arc 76, which gives me 38 degrees. Okay, so this larger angle in red here is 38. The trick is we need to subtract out this other part. Now, to do that, again, just like with the last problem, since both PS and PT are radii of the circle, I know we have an isosceles triangle, so these two angles here will be congruent. We also have 21 degrees in this lower corner. Okay, so to find the smaller angle, what we'll do is we'll go 38 minus 21, which will give me 17 degrees. Okay, so angle we're looking for here is going to be 17 degrees. Okay, and then also, again, the big thing we want to take from this problem is that relationship between the intercepted arcs and inscribed angles. We always know that that angle is going to be half the measure of the arc. Arc will be twice the measure of the angle. Problem 3 just asks, in the figure, what's the measure of angle C? Okay, so we want to find angle C here. And this deals with an angle that's not inscribed. It's not a central angle. It's just kind of somewhere else on the circle. Now for that, we had two formulas. If I have a circle and an angle placed randomly in the middle of that circle, okay, so not at the center, kind of off to the side here. Let's say here's my angle X we're dealing with. X is going to inscribe two arcs, and we could say that angle X is equal to 1/2 times arc plus arc. Okay, that was one case. That was when our angle was inside the circle. We could also have a situation like this where the angle's outside the circle. Okay, so let's say that in this case we have our angle X is outside. Again, the two sides of that angle are going to intercept two arcs. And when we're on the outside, we'd say that angle X is equal to 1/2 of arc minus arc. Okay, so inside the circle we'll do addition, outside we'll do subtraction. Okay, now with this one you're actually not given enough information. The picture's missing something. So to make things actually work, let's call this arc DE 140 degrees. Okay, then I can set up that angle C is going to be equal to 1/2 of arc of 100, okay, minus this other intercepted arc. And for that other intercepted arc, what we can do is we can go 360 minus 90 minus 100 minus 140. That'll give us what we're missing on this circle. When I do that, I get 30 degrees. Okay, so 100 minus 30 degrees. We end up with angle C is equal to 1/2 times 70, which is just equal to 35 degrees. Okay, so it looks like we have option B, 35 degrees. Again, the thing to take from this problem is our formula, kind of like with inscribed angles, but when we have the two different arcs, because we're talking about angle inside or angle outside of the circle, we'll actually have to combine those arcs. Addition when it's on the inside, subtraction when it's on the outside. Okay, we also looked at a couple problems dealing with circles in the coordinate system. Okay, circles with XY coordinates. Problem 4 asks, which graph represents the equation x minus 4 squared plus y minus 2 squared is equal to 16? Okay, that's going to use our standard form equation of a circle, which was set up as x minus h squared plus y minus k squared is equal to r squared. Okay, where the point h comma k is the center, and r is the radius. Okay, so we should be able to pull the center and the radius away from this equation here. Okay, so for our equation we have x minus 4, meaning that 4 is going to be the x-coordinate of our center. And y plus 2, that means that negative 2 is going to be the y-coordinate. Okay, so we want to find the circle centered at 4, negative 2. Okay, that looks like it's this one here. or possibly this one. Okay, then our radius, we're going to take a look at the 16 here. But it's actually going to be the square root of 16. Because remember, in our equation we have the radius squared. Square root of 16 is just a 4. Okay, meaning that we have 2, 4 for a radius here. It's only 3 for this one. Meaning option B is the correct answer. Okay, and last problem, problem 5, is going to deal with circles in the coordinate system once again. It says a circle with center -1, 2 passes through the point 2, -2, which is true. And there's some different info about the equation of the circle here. Again, we're going to use our standard form. If I know the center, I can fill that in. So we'd say x minus -1, so plus 1 squared plus y minus 2 squared. Okay, and then what we can do is, it looks like the other information relies on the radius, diameter, or knowing the radius for that equation. What we can do is figure that out using our distance formula. Okay, if we know the center and a point, the radius is going to be the distance between the two of them. So I can say my radius is equal to square root of, we'll go x minus x, so -1 minus 2 squared. Okay, plus in the same order y minus y, so 2 minus -2, so 2 plus 2 squared. That's going to give us square root of -3 squared, which would be 9, plus 2 plus 2 is 4, so 4 squared will be 16. Okay, which is the square root of 25, which is equal to just 5 here. Okay, so I could say equals 5. Right off the bat, that X's out option C because the radius is wrong. Okay, we also see from that radius is 5, it can't be square root 5. But if the radius is 5, double that, we'll get the diameter is 10. Okay, so we have option B, diameter of 10.